Hi students, in this video we are going to solve more problems related to the concept relation. Now I read the question. Let A is a set which contains the elements 1, 2, 3, 4, 5 and B is another set which contains the elements 1, 4, 5. Let R be a relation which is less than 1 from A to B. Then list the elements of R. And the next question is find the domain, codomain and range of R and depict the relation by an arrow diagram. In order to solve this problem, first we need to create A cross B. So we are writing A cross B. You know how to write A cross B. The first element in set A. Here A cross B, hence the first set should be A. Each and every element of set A should be taken. It must be connected to each and every element of set B. So 1, 1 and then this 1, 4 and then 1, 5. Next we take the second element in set A. This 2 is taken and it is connected with each and every element of set B. So 2, 1 and then 2, 4 and then 2, 5. Like this we will proceed and we get this set A cross B, Cartesian product of A cross B. We know that R is a relation which is the subset of A cross B. Hence, the set R must contain elements which are part of A cross B. Now, the relation is less than. The relation should be defined based on this context, that is less than. Now, if you take up this first one, 1, 1 is related to 1. So instead of this we will take up this one 4, 1. 4 is related to 1, right? This 4 is related to 1. Whether this element will be the part of set R or not, here based on this context we will check. Here the relation should be is less than. If you take up this 4 is less than 1, we need to say this 4 is less than 1. Is it right? No, it is not right. Hence 4, 1 cannot be the part of this relation set. So we have to check each and every element and then whether it satisfies this condition or not. If the elements in A cross B satisfies this condition, then those elements will be a part of set R. First we will take up 1, 1. Now we need to check the first one is less than the second one, that is 1 is less than 1. It is not satisfying, hence it cannot be the part of this set R. Next one is 1, 4. Now we need to read this as 1 is less than 4. Yes, obviously 1 is less than 4 in mathematics, hence 1, 4 should be the part of this set R. Then 1 is less than 5. This element of A cross B satisfies the condition is less than, hence it is the part of set R. Then 2, 1. 2 is less than 1. No, it is wrong. So it cannot be the part of this set R. 2 is less than 4. Hence it satisfies the condition. Of course, 2 is less than 4. Hence this must be the part of set R. 2 is less than 5. Yes, it is correct. Hence this element can be the part of set R. 3 is less than 1. It does not satisfy. So we cannot put this element in this set. 3 is less than 4. Yes. Hence we can put this element 3, 5. Yes, 3 is less than 5. Hence this 3, 5 can be the part of this set R. Now if you look at this set 4, 1, that is 4 is less than 1. It is wrong. 4 is less than 4. No, it is wrong. 4 is less than 5. Yes, it is correct. Hence it can be the part of this. 5 is less than 1. Sorry, it is wrong. 5, 4, that is 5 is less than 4. Wrong. 5, 5. 5 is less than 5. No, it does not satisfy the condition. Hence, these elements cannot be the part of it. So now, if you observe this relation set, it contains all the elements which belong to Cartesian product of A cross B. Hence, R is the subset of A cross B. Hence, this set qualifies as the relation set of A cross B. Now 1 is related to 4, 1 is related to 5, 2 is related to 4, like this. Now we need to write domain of R. Domain means set of all first coordinates of the elements. 1, 4 is the first element, 1, 5 is the second element, 2, 4, like this, in which we should take the first coordinate, that is 1, and then 2 and then 3, 4. So all the first coordinates of elements of set R forms a set. That set is called as domain R. Now range of R. Range of R means set of all second elements. Set of all second coordinates of the elements. So 4, 5, again 4, 5, 4, 5, 4, 5. Hence the range contains only two elements, 4, 5. Codomain means the set B. Here A cross B. B is the second set. This second set should be the codomain of R. Set B contains 1, 4, 5. So codomain of R is a set which contains 1, 4, 5. Now we need to express this relation R in terms of arrow diagram. So what we need to do is, first we need to list down all the elements of set A. Set A is represented by closed diagram, set B is represented by closed diagram, and all the elements of set A should be represented by dot. Here the set A contains 1, 2, 3, 4, 5. Here also you can observe all those elements are represented by dot diagram. And then set B. Set B contains 1, 4, 5. Here if you observe it, the elements 1, 4, 5 are represented by dots. Now we need to relate them with an arrow mark. 1 is related to 4, hence 1 is related to 4, and 1 is related to 5. 1 is related to 5, which is represented by arrow diagram. 2 is related to 4, 2 is related to 4, 2 is related to 5, and then 3 is related to 4, 3 is related to 5, and then 4 is related to 5. Here if you look at this, 5 is not related to any elements. I hope you understand this problem clearly. If you have clear idea in this problem, definitely you can understand all the concepts of domain, codomain, range, and what is the meaning of relation. Now we move on to next question. Let set A contains 1, 3 and set B contains 2, 3, 4. Find the number of relations from A to B. Now we need to check how many relations can be formed using these two sets. We know that relation is the subset of Cartesian product of A cross B. Hence, we need to find out number of subsets of A cross B. When set A, cardinal number of set A is equal to 2, it means that number of elements in set A is denoted as n of A. N of A means cardinal number of set A, and then cardinal element number of set B is 3. A cross B is obtained. Number of elements in A cross B is obtained by multiplying these two values. 2 into 3 is 6. Hence, in the Cartesian product of A cross B, we have 6 elements. You know that A cross B is a set which contains 6 elements. Now we need to find out how many subsets can be created using this set A cross B. We know the formula that number of subsets of a set can be obtained by 2 power number of element in the set. So number of subsets of A cross B is equal to 2 power number of elements in the set A cross B. Here number of elements in the set is 6, hence 2 power 6 is 64. It means that we can create 64 different subsets using the elements of A cross B. We know that all the subsets of A cross B can be called as different relations. Hence, every subset of A cross B can be considered as relation from A to B. Hence, there are 64 relations from A to B. I hope you understand this second problem as well. And these two problems are very important to understand the concept clearly. Thank you, students. Thanks for your cooperation.